Hello everyone, good evening. Welcome to the low level design class, and the topic for the day is relationships. So we all know about databases, we all know databases consist of different tables, but then comes the most important topic, that how are those tables related to each other? What are the kind of relationships that exist between the tables? And I hope you are already aware of different kinds of database concepts like primary keys, foreign keys, how the database stores the data in form of rows or records. So I hope that you have attended those previous sessions around databases. So in this session, we'll build upon that and we'll discuss in depth what are relationships between two tables. So starting off, primarily there are just three type of relationships between two tables. The first one is the one-to-one relationship. Then the second one is many-to-one relationship, and the third one is many-to-many relationship. And just a quick note here, the many-to-one relationship, it is also called as one-to-many or many-to-one. Both are basically the same thing. So the three relationships that we are talking about are also referred to as one-is-to-one relationship, one-to-one, or many-to-one can also be written as n-to-one or one-to-n relationship, and many-to-many relationship can also be written as n-to-n relationship. So these are the ways how we can define the three relationships that we have: one-to-one, many-to-one, and many-to-many relationships. And these relationships exist between two tables. So let's move on to deep dive into the one-to-one relationship first. So before we deep dive into any particular relationship, I just want to uh, answer the question that how do we define that whether the relationship between two tables is one-to-one, many-to-one, or many-to-many? Like which relationship should exist between two tables? So it's a very straightforward and simple way to identify that. And what you can do is you can use this two-step process. What is that two-step process? So the two-step process is that in the first step, what you do is you choose one table one record. So here T1 means table 1, right? So the relationship exists between table 1 and table 2, and you need to identify what is the relationship here, right? You have one table here, you have another table here, and these two are related, but you don't know what is the type of relationship among these two tables. It could be one-to-one, one-to-n, n-to-n, but you don't know what that relationship is. So to identify that, what you can do is you can follow this two-step process, right? So let's see what it is saying. It says choose one table 1 record and check how many table 2 records can be related to it. So it's like a lot of things, but we'll definitely look at with an example as well. And what is the second step? Now moving on to the second step, it's basically the same thing, but you just invert the places of table 1 and table 2, right? So here you are saying that you choose one record from table 1 and check how many records in table 2 can be related. You have to check how many maximum table 2 records can be related. This is the step 1, and the step 2 is basically just swapping the table 1 and table 2 here. That what you do now in the step 2 is that you choose one record from table 2, you choose one record from table 2 this time around, and you check how many table 1 records can be related, right? You have to look at that. So let's see this in action to understand it better. I know right now it might not make a lot of sense, but yeah, let's look at an example, right? So this is an example of one-to-one relationship, but we'll see how this makes sense, right? So let's say we have a database of some employees in our company, and we have one table that stores the employee information, right? So this is what our employee table looks like. It is very small table. It has an ID column, a name column, and a third column that stores the Aadhaar information of the user. Basically, this is a foreign key to the Aadhaar table, correct? And we have another table called the Aadhaar table. What does it store? It stores very basic details, the ID and the Aadhaar number. That's it. Here is a 12-digit Aadhaar number, and here is the ID of this particular row. That's what our Aadhaar table consists of. Yeah, I know it looks like a very basic kind of a table, but just bear with me for explanation of this particular concept. So let's see how we can apply this two-step process, right? What are we saying here? Like, we need to choose one record from table 1 and check how many table 2 records can be related to it, correct? So let's do that. Let's pick one particular record. So any record, we can pick any record, right? One employee. So if I pick any one employee from the employee table, what do you think? How many Aadhaar could be associated with one particular employee? So in a real world situation, do you think that Aadhaar number of one particular employee could be like 2 or 3 different Aadhaar, or is it that one particular employee can only have one particular Aadhaar? What makes sense? Yeah, definitely. So if I have one employee, then definitely I will have just one Aadhaar related to that employee, and that's like that is always going to be the case. It can never be more than one, never. So at max, one table, one record, like one record from the employee table, one record from the employee table associates with just one record on the Aadhaar table, right? One record from the employee table associates with one record on the Aadhaar table. This was my step 1. Now step 2. Step 2 is just doing the same thing but from the other way around. So let's look at that as well. Now what we are trying to see? We are trying to see one Aadhaar number. We'll pick any random Aadhaar number from here. If we pick one Aadhaar number from here, what do you think? How many users might be related to this Aadhaar number? Is it possible that this Aadhaar number belongs to Akash as well as it also belongs to Aman? Is it possible? Yeah, no, not at all, right? So on the other way around, if I talk about like one Aadhaar record will also belong to only one particular employee, not more than that. One Aadhaar number will always belong to one particular employee only. So this particular kind of relationship where both the sides we have a 1:1 relationship, this relationship is a 1:1 relationship or a 1:1 relationship. So the employee Aadhaar relationship, EMP Aadhaar relationship, is a 1:1 relationship, right? Makes a lot of sense. Every employee has an Aadhaar number and only one Aadhaar number, and similarly every Aadhaar number is associated to only one and one employee. That's it. And to manage this relationship, we have created this field called Aadhaar on the employee column, which is basically a foreign key to the Aadhaar table. So this particular field Aadhaar is also a foreign key to this particular table Aadhaar, right? What we could also do was we could also have created employee column on the Aadhaar table instead, right? We could have gotten rid of this foreign key from employee table, and we could have created the foreign key here on the Aadhaar table, and that foreign key would point to the employee table, right? And we would have stored the IDs here, right? Employee IDs in this column, and this would be the foreign key. So for a one-to-one relationship, we can utilize any table, either the first table or the second table, and dedicate a foreign key column to the other table. So that foreign key could exist in the employee table, that foreign key could exist in the other table as well. So this looks pretty straightforward. Now let's move on to the slightly more interesting case of one-to-many relationship. So for that, I have taken a slightly different example where I have the same employee table, and then I have another table which contains the countries, list of countries that we support, right? That the employees can have. So again, the employee table has three columns: the ID column, name column, and the country column. And the country column has the two columns. Country table has the two columns, ID and the name. So let's suppose the data that we have is like we have three employees, Aman, Zia, and Sam, and then they belong to the countries like India, USA, and Canada. So let's suppose we only support three countries. We only have offices in India, US, and Canada. So we only have three countries in our database, and then we have three employees as well, Aman, Zia, and Sam. So let's try to apply the same logic here. How do we determine the relationship between these two tables, right? So what we do is we check like one particular record from the employee table. How many associations can it have to the country table, right? If I have, let's say, Aman or any employee, one employee, how many countries can he belong to, right? So logically we know that every employee can belong to only one country, right? One employee can belong to exactly one country, right? It is not possible for one employee to be employed in more than one countries, right? So this is going to be a one employee to one country. So this was my step one. Now let's look at step two. What do we look at? Step two is that we pick one country from the list, right? We pick one country from here. So if I choose, like, let's say, if I say one country, right? One country. So one country can be associated with how many employees? That is the main question. How many employees? So currently in our database, we can see that every employee belongs to a unique country, but that's not going to be true forever, right? It's not going to be true forever. So one country, let's say India. India already has Aman, but again, we can also say, like, we can also hire a new person, fourth person. Let's say fourth person, we hire a fourth person named Akash, and he also belongs to India, right? This could also be the case. So now we cannot say that for every country we have exactly one employee, right? That does not make sense, because one country we could have multiple employees as well, right? Aman is also from India, Akash is also working from India. So in this case, what do we have? We have the relationship 1 to n. So for one country we have n possible employees, right? Because either we choose like 1 to 1 or 1 to n, but in this case, we what makes more sense is that for one country there could be n number of employees, hence this is a 1 to n relationship. So this is how we identify the relationship 1 to n relationship. Now we have defined that this is a 1 is to n relationship. Now let's look at one more interesting thing that we looked before. What's the foreign key here, right? We have created the foreign key country on the employee table, and that works fine. But why? If we try to create the foreign key on the country table, then we won't be able to do that. Why? Because let's say we have the country India, we have ID, one country name is India, and then we have to identify which employee should be associated with this country. So I cannot identify one specific employee that should be associated with this country India, because there could be multiple, right? Aman could also be associated with India, Akash could also be associated with India. So we cannot have the primary key created on the country table, right? Because country table will have multiple associations for the same record, and when there is the possibility of multiple associations on the same record, we never use that table to create a foreign key on that table. So if we look at it the other way around, on the employee table, for every employee we are 100% sure that every employee will have only one country, and that's it. Aman cannot be working from more than 2 countries under any circumstances. So this is a safe bet to use the foreign key country on the employee table. Hence, here it makes sense to have the foreign key on the employee table, and if we try to create it on the country table, it will be incorrect, it will be incompatible, and we would not be able to store the correct information if we create the employee table, if we create the employee foreign key on the country table. So this is incorrect. So I hope this makes sense. Let's move on to the third and the final concept of the day, which is the many to many relationship. So this is also called as N to N relationship or many to many relationship. So for this, I have a slightly different example. So let's suppose we are building system for a college which offers courses, right? These are some courses that the college is offering. So it offers 3 different courses, one in artificial intelligence, one in SQL, and one in data structures and algorithm, DSA. Now the company or the college that we have here that is offering these courses, it has the condition, right, that you need to select 2 courses and exactly 2 courses. That you have to select exactly 2 courses to be a part or be a student of this particular college, right? So this is the condition that is imposed by the college itself, and we have to build a system for this particular college around this condition. So let's look at how we can determine what relationship should we keep between these 2 tables, right? So let's use our same 2-step formula. Step 1, let's check for one particular let's check for one record from the user table, right? So we know that if we take one record from the user table, we should have 2 courses for it. 2 courses for it. So definitely it is going to be a 1:n relationship, because for one user we need to have 2 courses, correct? One user has to take 2 courses, then the relationship is 1:n between user and course. Now let's move on to the second step. What was the second step? We swap the tables. So let's look at the other way around. So if I pick up one course, right? If I pick up one particular course from here, one particular course from this table, let's say AI, how many students can take the AI course? Yeah, great, correct. N students can take. So Aman can also take AI, Vipul can also take AI, and Anshu can also take AI. So everybody has the option to choose AI, and Aman can also choose SQL along with AI. So similarly, like if we look at the other way around, one course, it is related to how many users? Again, so it can be related to n users, correct? We cannot say that one course can only be opted by just one student. That's not right, right? That does not make sense. If it's a course, multiple users or multiple students can take that particular course. So again, in this case, what we find out, the relationship in step 2 also comes out to be 1 is to n. And when both the steps give you 1 is to n as their relationships, then the final relationship between the two tables is n is to n. Hence, this is the case of an n is to n or a many to many relationship. Right. So now we come to the problem. Like, how are we going to define the relationship between these two? How am I going to find out Aman, how many courses Aman has opted for? So I cannot create a foreign key column on the user table, because if I try to create a foreign key for courses, this is a foreign key, but this would not make sense because Aman can have AI, Aman can also choose SQL. So how do I specify two different ITs in one particular column, in one particular cell? So it's not possible to have the foreign key on the user table. What else can we do? Let's look at how it will happen if we try to use the foreign key on the courses table. So if I try to create a user foreign key on the courses table, again this won't work because AI might have been taken by Aman as well, Vipul as well. SQL might have been taken by Vipul, Anshu. TSA might have been taken by Aman and Anshu. This is a very valid use case because one particular course can be taken by multiple users. Hence, we cannot define the foreign key on the courses table as well. So now this is a problem. We cannot define the foreign key on the user table. We cannot say that Aman has one particular course, because again Aman has to definitely take two courses. Similarly, on the on the other side of the things, on the course table, I cannot define a foreign key to the user table, because again AI as a course might be taken by Aman, might also have been taken by Vipul or any other students as well. So again we cannot specify n different related objects or related records in one particular column, foreign key column, right? So this is a problem. We cannot define a relationship. uh, like, how do we define this relationship? How do we manage the n is to n relationship between the two tables? So this happens in all n is to n relationships, many to many relationships, and the solution for this is actually very simple, and that is that we create a third table. We simply create a third table Yeah, so we simply create a third table and let's call it the user course table. So it has the ID column, it has user column, it has the course column, right? So what do we store in this table? This is sort of a joining table between the user table and the course table. So this can be treated as an intermediate table between the user and the course table. This table is called a user course table. And what will it contain? It will contain ID 1. It will contain the user ID. Let's say user ID is 1 for Aman, and Aman has taken, let's say Aman has enrolled to AI as well as SQL courses. So we can say that Aman user is Aman. I'm just writing the name for easy to read, to make it easy to read. And he has taken the AI course. Similarly, we'll add a second row where we'll say Aman has taken the SQL course as well. Then we can do the third row where we talk about Vipul. Vipul has taken the SQL course. Then we can create the fourth row. Vipul has also taken the DSA course. Similarly, we can create 5 and 6 as well, where we say Anshu has taken the AI course and Anshu has also taken the DSA course. So this is how my joining table or the intermediary table between user and course looks like. And now my relationship is established fine, because I know if I am talking about Anshu, I can just write a query to fetch all the records from the user course table where the name is Anshu. So I'll get these two rows and I will get to know that, hey, AI and DSA, both of these courses are Anshu's courses. And similarly on the other way around, if I want to know how many users have taken up AI as their course, I can just simply write another query where I can just pick this user course table and select from this user course table and add the condition that course should be equal to AI. So let me just write the dummy query as well. Fetch all users in AI course. So what will that query look like? That will be a very simple query saying select star from user course table where course is equals to AI. So what will this return? This query will simply return this particular record and this particular record, Aman and Anshu. So I can select like who all users have taken AI as their course. So this was the whole concept of relationships. We discussed all the three types of relationships: the one-to-one relationship, many-to-one relationship, and many-to-many relationship. And we also saw how we can define these relationships in actual tables, and how we can define the foreign keys, and which table we can use to define the foreign key on. And for many to many, we looked how we can create a joining table, because for a many to many or n is to n relationship, we cannot define a foreign key directly on one of the two tables. So I hope this class was clear. Let me know in case of any doubts. Thank you so much.